Hi, welcome to today's video about the sub-Neptune K2-18b. This is a world with potential for life. A nice image of the Kepler Space Telescope. This was a big scientific success. As you can see on the right side, it uses the transit method for the detection of exoplanets. So a planet of the size of Jupiter can dim a sun-like G-star by 1%, and a terrestrial planet like Earth or Venus cause a dimming by just 1/10,000th. The Kepler Space Telescope and the follow-up missions found over 2,700 planets. And thanks to the Kepler Space Telescope, we now know that there are 5 billion Earth-sized planets in the habitable zone of a G-type star, like the Sun, in the Milky Way. This is a picture of the K2 mission. So Kepler Space Telescope had a problem in 2013. Two of the four reaction wheels failed, and you need a minimum of 3 reaction wheels. So the scientists and engineers used a trick. They used the solar wind for realignment. They used the photon pressure on the solar planets to reposition the Kepler mission, the Kepler Space Telescope. And that made the second life, the K2 mission, Kepler Space Telescope, possible. This is a nice picture of the nearby stars around the Sun. The Sun is here, the G-star, yellow dwarf. All these stars in the minor arm, the Orion arm, in the Milky Way galaxy. You can see most of the stars are these red dwarf stars, also called M stars. They make 75% of all stars. And there are orange dwarfs, K stars, like Alpha Centauri b. They make 12%. And the Sun-like stars, the G stars, make only 8% of all stars. This is an image of the red dwarf K2-18 from the Sloan Digital Sky Survey. Another M star red dwarf at a distance of 124 light years. It has half the mass of the Sun and just 2% of the Sun's luminosity. Its temperature is 3,500 Kelvin. That's 2,000 Kelvin less than the surface temperature of the Sun. The age of the star is about 2.4 billion years. That's about half the age of the solar system. The system contains 2 planets. This is an overview of the K2-18 system. There's an inner planet that's K2-18c. This is a small gas giant with a mass of 6 Earth masses. It is just at a distance of 0.07 AU, and its orbital period is 9 days. The outer planet is more interesting. That's the K2-18b, because it's very close to the habitable zone of this red dwarf. This artist's image of the inner planet K2-18c. It is a gas dwarf, also called a sub-Neptune. And these types of planets are known to be more common than Neptune-sized planets. This is an artist's image of the other second planet, K2-18b, which is a sub-Neptune. Has a hydrogen layer. Its mass is 9 Earth masses. It is at a distance of 0.16 AU. 1 AU is the Earth-Sun distance. And the orbital period of this planet is 33 days. And the Hubble Space Telescope was able to measure 8 transits of this planet. Another artist's image of this planet, K2-18b, gas dwarf sub-Neptune. Its density is 2.7 grams per cubic centimeter. That's right between the higher density of Earth and the lower density of Neptune. The average temperature on this planet could be between -27 to +23 degrees Celsius. This planet could be a Hycean planet, which is a hot water-covered planet with a hydrogen atmosphere. Because it is so close to the star, it's probably tidally locked. In this picture, you can see at the left side clouds. The clouds are very important because they determine the albedo of this planet, reflectivity, and this is important for the average temperature on this planet. This is another artist's image of this planet, K2-18b, the Hycean planet with the H2 envelope. Its ocean could be with supercritical water. That's water at a higher pressure and temperature. And the question is, are these conditions good enough for biological activity? This is an infrared spectrum, near-infrared spectrum of the James Webb Space Telescope of the planet K2-18b. You can see the signals of methane, here, and carbon dioxide. And there are two signals that could be from the molecule DMS, which is dimethyl sulfide. This is a structure of dimethyl sulfide, black carbon atoms, white hydrogen atoms, S atoms, sulfur atoms in yellow. DMS is a metabolism product of life from the phytoplankton. And on Earth, it is also a product of industrial processes. This is another artist's impression of the planet K2-18b. And we need more observations with the James Webb Space Telescope to find more about this fascinating planet, potential planet with life. This is a nice animation of the formation of a ring around an exoplanet. All these giant planets have probably rings and several moons. Because it is very likely that some of the material is left over, it cannot be used for the formation of the moons. So that makes the rings. Or collisions of moons can also contribute to rings. This is a nice art from the Kepler Mission retirement. The Kepler Mission was from 2009 to 2018. It contains the detected planets and systems. And I will add the links to this art and to the scientific papers in the description field. You can check them out. And that was today's video about the fascinating planet sub-Neptune K2-18b, potential planet with life. Thank you for watching. Have a nice day. Bye bye.